The air around us is not a single thing, but rather a collection of gentle layers, each one resting quietly above the one below it. These layers wrap around the entire planet, soft and invisible, holding everything in place with a touch so light that we rarely notice it is there at all. The atmosphere begins right where we are, at the surface of the Earth, and extends upward in a slow, steady progression, growing thinner and calmer as it rises. There is no sharp boundary, no clear line where one layer ends and another begins, only a gradual shift, a slow transition from the thick, familiar air we breathe to the thin, quiet stillness that exists high above. The lowest layer of the atmosphere is the one we live in, the one that touches the ground and moves gently through the trees. This layer is called the troposphere, and it is where all of our weather happens, where clouds form and drift, where rain falls softly to the earth. The air here is relatively dense, filled with the water vapor that rises from oceans and lakes, the particles that have been lifted by the wind. This is the layer that supports life, the layer that provides the oxygen we breathe and the moisture that nourishes plants. It is a busy layer, in its own quiet way, with air constantly moving, rising when it is warm, sinking when it is cool, circulating in gentle patterns that shift and change over time. The troposphere is not very tall, comparatively speaking. If you were to travel upward from the surface, you would find that this layer extends only a certain distance before it begins to give way to something different. Near the equator, where the sun's warmth is strongest, the troposphere reaches a bit higher, the warm air expanding and pushing the boundary upward. Near the poles, where the air is cooler, the troposphere is shorter, more compressed. But everywhere, it is the layer that contains the weather, the layer where clouds gather and disperse, where the wind blows and the temperature changes from day to day. Within this lowest layer, the air is warmest near the surface. The ground absorbs energy from the sun and releases it slowly, warming the air that rests just above it. This warm air is lighter than the cooler air above, and so it rises, drifting upward in soft, invisible currents. As it rises, it expands, and as it expands, it cools, releasing the warmth it carried from the surface. This process continues, a gentle cycle of rising and cooling, and it is this cycle that creates much of the movement we see in the sky. Clouds form when the rising air cools enough for the water vapor it carries to condense into tiny droplets, gathering together in soft, drifting masses that float through the sky. The temperature in the troposphere decreases as you move higher. Near the surface, the air might be warm and comfortable, but as you rise, it becomes cooler, the warmth of the ground left farther and farther behind. This cooling is steady and predictable, a slow decline that continues until you reach the top of the troposphere. The rate at which the temperature drops is gentle, not sudden, and it varies slightly depending on how much moisture is in the air, but the overall pattern remains the same. Upward means cooler, always, in this lowest layer of the atmosphere. The wind we feel at the surface is part of this layer's movement. Air flows from places where it is dense and heavy to places where it is lighter, creating currents that move horizontally across the landscape. These currents are influenced by the rotation of the Earth, which gently deflects them, causing them to curve rather than move in straight lines. The result is a complex pattern of winds, some steady and reliable, others shifting and variable, all of them part of the slow, continuous circulation of air within the troposphere. The wind carries warmth from one place to another, moisture from the oceans to the land, and it does so quietly, persistently, day after day. Above the troposphere, the atmosphere changes. The transition is gradual, but at a certain height, the cooling stops. The temperature no longer decreases as you move upward. Instead, it begins to stabilize, and then, slowly, it begins to increase. This marks the beginning of the next layer, a region where the air is thinner, calmer, and where the weather we know does not exist. This layer is called the stratosphere, and it is a place of stillness compared to the busy troposphere below. The air here is less dense, the molecules spread farther apart, and there is very little vertical movement. The stratosphere is a quiet layer, a place where the air sits in gentle, stable layers, undisturbed by the churning currents below. The stratosphere extends upward from the top of the troposphere, rising steadily higher above the surface of the Earth. Within this layer, the air is dry, almost devoid of water vapor, and because of this, clouds are rare. The few clouds that do exist here are thin and wispy, made of ice crystals that form under very specific conditions. These clouds are not like the soft, billowing clouds of the troposphere. They are delicate and fleeting, existing only in the coldest, most stable parts of the stratosphere, and they contribute little to the weather patterns we experience on the ground. One of the defining features of the stratosphere is the presence of ozone, a form of oxygen that exists in higher concentrations in this layer than anywhere else in the atmosphere. Ozone molecules are made of 3 oxygen atoms bound together, and they have the ability to absorb certain types of light from the sun, particularly the ultraviolet light that can be harmful to living things. When ozone absorbs this light, it converts the energy into heat, and this is what causes the temperature in the stratosphere to increase with height. The higher you go within this layer, the more ozone there is, and the warmer the air becomes. It is a gentle warming, not dramatic, but it is enough to create a layer of relative warmth high above the cold upper reaches of the troposphere. This layer of ozone plays a quiet but essential role in making life on the surface possible. By absorbing ultraviolet light, the ozone prevents much of this energy from reaching the ground, where it would otherwise damage the cells of plants and animals, including humans. The ozone layer is thin, and if you were to compress all of the ozone in the stratosphere into a single layer at the surface, it would be quite small, but spread out as it is over a large volume of atmosphere, it is effective at filtering the sun's rays. The ozone exists not as a distinct shell, but as a diffuse presence, with concentrations that vary slightly from place to place and from season to season, but always performing its protective function. The air in the stratosphere is stable. Because the temperature increases with height, there is little tendency for air to rise. Warm air already sits above cooler air, and this is a stable configuration. In the troposphere, warm air rises because it is lighter than the cool air above it, but in the stratosphere, this does not happen. The air remains in place, layered and still, moving horizontally if at all, but rarely mixing vertically. This stability is part of what makes the stratosphere so different from the layer below. It is a place of calm, where the air does not churn and roil, where the conditions change slowly, if at all. Aircraft sometimes fly in the lower parts of the stratosphere, taking advantage of the smooth, stable air and the absence of weather. Up here, there are no storms, no turbulence caused by rising and sinking air, only a steady, gentle flow. The air is thin, too thin to breathe, but it is calm, and this makes it an ideal place for long flights that need to cover great distances efficiently. The stratosphere is a layer that exists above the everyday concerns of weather, a place where the sky is darker, clearer, and where the horizon begins to curve noticeably, a reminder of the planet's roundness. As you move higher still, beyond the stratosphere, the atmosphere continues to thin. The transition from one layer to the next is not abrupt, but rather a slow, steady change. The stratosphere gives way to another layer, one where the temperature once again begins to decrease with height. This next layer is called the mesosphere, and it is a region of the atmosphere that is rarely thought about, rarely visited, and yet it exists, quietly, high above the surface of the Earth. The mesosphere is colder than the layers below it. As you rise through this layer, the temperature drops steadily, becoming colder and colder until you reach the upper boundary, where the temperature is lower than anywhere else in the atmosphere. This is a place of extreme cold, though it is difficult to imagine, so high above the warm surface of the planet. The air here is very thin, too thin to support any kind of weather as we know it, too thin to carry sound effectively. It is a silent, cold, and isolated layer, one that exists in a kind of twilight, neither fully part of the lower atmosphere nor yet part of space. In the mesosphere, the air is still thick enough to cause friction. When small particles from space, tiny fragments of rock and dust, enter the atmosphere, they encounter the air of the mesosphere and begin to slow down. The friction between these particles and the air molecules generates heat, and the particles begin to glow, burning up in bright streaks of light that we see as meteors. Most meteors burn up completely in the mesosphere, never reaching the surface, their energy dissipated in a brief flash of light high above the Earth. The mesosphere is where the atmosphere begins to protect the planet from these small visitors from space, quietly catching them and turning them into harmless trails of light. The mesosphere is also a place where certain kinds of clouds can form, though they are nothing like the clouds we see from the ground. These clouds, sometimes called noctilucent clouds, form at the very top of the mesosphere, in the coldest part of the atmosphere. They are made of tiny ice crystals, so small and so high that they can only be seen when the sun is just below the horizon, illuminating them from beneath while the surface below is in darkness. These clouds are rare and delicate, visible only under very specific conditions, and they exist at the boundary between the atmosphere and space, a thin, ghostly presence in the high, cold air. The air in the mesosphere is far too thin to breathe, far too thin to support life as we know it. There are no birds here, no insects, nothing that flies under its own power. It is a layer that exists beyond the reach of living things, a place that is defined more by what is absent than by what is present. The air pressure is extremely low, the air molecules spread so far apart that they barely interact with one another. And yet, this layer is still part of the atmosphere, still connected to the layers below, still playing a role in the overall structure of the air that surrounds the planet. Above the mesosphere, the atmosphere becomes even thinner, and the temperature begins to rise again. This marks the beginning of the thermosphere, a layer where the air is so thin that traditional ideas about temperature begin to break down. In the thermosphere, the few air molecules that exist move very quickly, absorbing energy from the sun and vibrating with great intensity. If you were to measure the kinetic energy of these molecules, you would find that they correspond to very high temperatures, far higher than anything we experience on the surface. But because the air is so thin, there is very little actual heat. The molecules are energetic, but there are so few of them that they cannot transfer their energy effectively. You would not feel warmth in the thermosphere, even though the temperature, in a certain sense, is very high. The thermosphere is where the atmosphere begins to merge with space. The air here is so thin that it offers almost no resistance to objects moving through it. Satellites orbit within the thermosphere, circling the Earth in the near vacuum, moving freely without the drag that would slow them down in the lower atmosphere. The thermosphere extends quite far above the surface, rising to heights that would seem unimaginable, and yet even here, there are still air molecules, still traces of the atmosphere, clinging tenuously to the planet. Within the thermosphere, particles from the sun sometimes interact with the air in spectacular ways. The sun emits a constant stream of charged particles, a solar wind that flows outward into space. When these particles reach the Earth, they are guided by the planet's magnetic field toward the poles, where they collide with their molecules in the thermosphere. These collisions cause the air molecules to glow, creating shimmering curtains of light that dance across the sky, visible from the surface as auroras. The colors of the auroras depend on which molecules are being excited and at what altitude the collisions occur, but the effect is always the same, a soft, ethereal glow, a reminder of the invisible forces at work high above the Earth. The thermosphere is a layer of transition, a place where the atmosphere is still present but where the characteristics of space begin to dominate. The air is too thin to carry sound, too thin to support combustion, too thin to be breathed. And yet, it is not yet space. There are still molecules here, still a tenuous connection to the denser layers below, still a part of the planet's protective envelope. Higher still, beyond the thermosphere, is the exosphere, the outermost layer of the atmosphere. The exosphere is barely an atmosphere at all. The air here is so thin that molecules rarely collide with one another. They move in long, arcing paths, influenced more by gravity and the sun's radiation than by interactions with other molecules. Some molecules in the exosphere have enough energy to escape the Earth's gravity entirely, drifting off into space, lost to the planet forever. Others fall back, pulled by gravity into the denser layers below. The exosphere is a place of slow leakage, where the atmosphere gradually thins until it merges imperceptibly with the vacuum of space. There is no clear boundary where the exosphere ends and space begins. The transition is so gradual that it is impossible to say with certainty where one stops and the other starts. The atmosphere simply fades, growing thinner and thinner, until the few remaining molecules are so sparse that they no longer constitute an atmosphere in any meaningful sense. This outer edge of the exosphere extends far from the surface, reaching distances that would take hours to travel even at the speeds of the fastest aircraft. And yet even here, there are still traces of the Earth's atmosphere, faint echoes of the dense air below. The atmosphere as a whole is a thin shell compared to the size of the planet. If the Earth were the size of an apple, the atmosphere would be thinner than the apple's skin, a delicate layer wrapped around the solid mass beneath. And yet, this thin layer is essential. It provides the air we breathe, the pressure that keeps water liquid on the surface, the protection from harmful radiation and from the small debris of space. It moderates temperature, distributing warmth from the equator to the poles, preventing the planet from becoming too hot during the day or too cold at night. The atmosphere is held in place by gravity, the same force that keeps us anchored to the surface of the Earth. Gravity pulls the air molecules downward, keeping them close to the planet, and the weight of all the air above presses down on the air below, creating pressure. This pressure is greatest at the surface and decreases steadily as you move higher, a natural consequence of having less and less air above you. The atmosphere does not have a sharp edge. It simply thins, gradually, until there is nothing left. Within each layer of the atmosphere, the air has its own characteristics, its own temperature profile, its own behavior. The troposphere is warm at the bottom and cool at the top, full of weather and movement. The stratosphere is stable and warming with height, home to the protective ozone layer. The mesosphere is cold and quiet, a place where meteors burn and rare clouds form. The thermosphere is energetic but thin, a transition zone between atmosphere and space. The exosphere is the final whisper of the atmosphere, a region where molecules drift away into the void. The layers do not exist in isolation. They are connected, part of a single, continuous system. Air circulates between them, though the circulation is slow and subtle. Energy from the sun drives processes in all the layers, warming the surface, creating the ozone, energizing the thermosphere. The rotation of the Earth influences the movement of air in the troposphere, creating patterns of wind and weather. The magnetic field of the Earth guides charged particles in the thermosphere, creating auroras. Everything is connected, everything influences everything else, in ways that are often too slow or too subtle to notice, but which are always present. The atmosphere is transparent, allowing light from the sun to pass through and reach the surface. But it is not completely transparent. It scatters light, bending it, spreading it, changing its direction. This scattering is what makes the sky appear blue during the day. The molecules of air scatter the shorter wavelengths of light, the blues and violets, more than they scatter the longer wavelengths, the reds and yellows. When we look at the sky, we see this scattered blue light coming from all directions, a soft, even glow that fills the sky from horizon to horizon. At sunrise and sunset, the light from the sun passes through a greater thickness of atmosphere before reaching our eyes. This longer path means more scattering, and the shorter wavelengths are scattered away entirely, leaving only the longer wavelengths, the warm reds and oranges, to color the sky. The atmosphere acts as a filter, changing the quality of the light, painting the sky in soft, shifting hues that change gradually as the sun rises or sets. The colors are gentle, never harsh, a slow transition from darkness to light or from light to darkness. The atmosphere also holds moisture, water vapor that has evaporated from the surface and risen into the air. This water vapor is invisible, but it is always present, especially in the lower atmosphere. When the air cools, the water vapor condenses, forming tiny droplets that gather together as clouds or fog. These droplets are so small that they remain suspended in the air, drifting with the wind, reflecting light and creating the white, gray, or sometimes dark appearance of clouds. The moisture in the atmosphere is part of a constant cycle, water evaporating from the surface, rising into the air, condensing into droplets, falling back to the surface as rain or snow, and then evaporating again. This cycle of water is slow and continuous, a gentle circulation that connects the ocean, the air, and the land. Water spends time in each part of the cycle, sometimes days in the atmosphere, sometimes years frozen in ice, sometimes centuries in the deep ocean. But it always moves, always cycles, always returns eventually to the atmosphere, ready to rise and fall again. The atmosphere is a temporary home for this water, a place where it rests briefly before continuing its journey. The air we breathe is a mixture of gases, each one present in different amounts. Nitrogen makes up the majority of the atmosphere, a stable, unreactive gas that fills the space around us. Oxygen is the next most common, the gas that we need to survive, the gas that fuels the processes of life. There are smaller amounts of other gases as well: argon, carbon dioxide, water vapor, and trace amounts of many others. Each gas contributes to the overall character of the atmosphere, each one playing a role in the complex system that surrounds the planet. The composition of the atmosphere has changed over time. Billions of years ago, when the Earth was young, the atmosphere was very different, filled with gases that would be toxic to us now. Over time, living things changed the atmosphere, adding oxygen through photosynthesis, removing carbon dioxide, altering the balance of gases until the air became what it is today. This process took a very long time, hundreds of millions of years, and it continues still, though much more slowly. The atmosphere is not static. It is a living system, constantly being shaped by the processes happening on the surface and in the air itself. The atmosphere protects the surface from the harshness of space. Space is a vacuum, cold and empty, filled with radiation that would be harmful to life. The atmosphere absorbs much of this radiation, preventing it from reaching the surface. It also provides pressure, keeping water in its liquid form, allowing the oceans and lakes to exist. Without the atmosphere, water would either freeze or evaporate, and the surface of the Earth would be a barren, inhospitable place. The atmosphere creates the conditions that make life possible, and it does so quietly, invisibly, without any effort that we can perceive. The atmosphere also helps to regulate temperature. During the day, the surface absorbs energy from the sun and warms up. At night, this energy radiates back into space, and the surface cools. The atmosphere slows this cooling, trapping some of the outgoing energy and preventing the temperature from dropping too quickly. This is a gentle effect, but it makes a significant difference. Without the atmosphere, the surface would become very hot during the day and very cold at night, swinging between extremes that would be difficult for life to tolerate. The atmosphere smooths out these extremes, creating a more stable, moderate environment. High in the atmosphere, the air is so thin that it offers little resistance to light or radiation. The sun's energy passes through almost unimpeded, and the stars are visible even during the day, their light not overwhelmed by the scattered glow of the sky. This is the realm where the atmosphere begins to lose its grip, where the planet's influence starts to fade, and where the conditions of space start to take over. It is a boundary region, a place of transition, where the familiar gives way to the unknown. The atmosphere is always present, always surrounding us, even though we rarely think about it. It is invisible and weightless to our perception, and yet it is always there, pressing down on us, filling our lungs, moving past us as the wind. It is easy to take for granted, but without it, life as we know it would not exist. The atmosphere is a gift, a protective layer that has been shaped over billions of years into something that can support the incredible diversity of life on the surface. As you rise higher and higher through the atmosphere, the air becomes thinner and thinner, the pressure lower and lower, the temperature changing in complex ways depending on which layer you are in. The journey upward is a journey into increasing isolation, into a realm where the air no longer behaves as we expect, where the familiar rules of weather and temperature no longer apply. It is a journey into stillness, into cold, into the quiet emptiness that exists at the edge of space. And yet, even in the highest reaches of the atmosphere, there is still a connection to the surface below. The air molecules that drift through the exosphere were once part of the dense air we breathe. The energy that warms the thermosphere comes from the same sun that warms the surface. The processes that create auroras are driven by the same magnetic field that protects us from harmful radiation. Everything is connected, everything part of a single system, a thin shell of air wrapped around a rocky planet, spinning slowly through space. The atmosphere is a layer of protection, a layer of life, a layer of gentle transitions and slow changes. It is a place where weather happens, where clouds form and dissipate, where the wind blows and the temperature shifts. It is a place where light is scattered, where water cycles, where gases mix and react. It is a place where meteors burn and auroras glow. It is a place that extends from the ground beneath our feet to the edge of space, a continuous gradient from dense to thin, from warm to cold and back to warm, from busy to still. The atmosphere does not have a voice, does not make grand pronouncements, does not call attention to itself. It simply exists, doing its work quietly, invisibly, day after day, year after year. It has been here far longer than we have, and it will continue long after we are gone, circulating air, distributing heat, protecting the surface, holding the water that makes life possible. It is a constant presence, a reliable companion, a thin layer of gas that makes everything else possible. As you imagine yourself rising through these layers, moving slowly upward from the warm, dense air of the troposphere to the thin, quiet stillness of the exosphere, you are tracing a path from the familiar to the unknown, from the comfortable to the extreme, from the everyday to the extraordinary. Each layer has its own character, its own temperature, its own role to play. And yet they all blend together, one into the next, forming a seamless whole, a continuous atmosphere that wraps around the planet in gentle, invisible layers. The troposphere, where we live, is a place of constant change. The weather shifts, the temperature varies, the wind blows and then calms. Clouds form and drift and dissolve. Rain falls and then stops. The sun shines and then is hidden. It is a dynamic layer, full of movement, full of life, full of the processes that make the surface habitable. The air here is thick enough to breathe, thick enough to carry sound, thick enough to support birds and insects as they fly. It is a comfortable layer, a familiar layer, the layer that defines our everyday experience of the world. But as you rise, the air becomes thinner, the weather fades away, and the atmosphere takes on a different character. The stratosphere is calmer, more stable, a place where the air sits in layers rather than churning and mixing. The temperature here increases with height, a counterintuitive fact that is explained by the presence of ozone, quietly absorbing ultraviolet light and converting it to heat. The stratosphere is a protective layer, filtering the sun's rays, allowing life on the surface to exist without being damaged by excessive radiation. It is a quiet guardian, doing its work without fanfare, without any acknowledgement from those it protects. Higher still, the mesosphere is a place of cold and isolation. The temperature drops again, reaching its lowest point at the top of this layer. The air here is too thin to support any kind of weather, too thin to carry heat effectively. It is a layer where meteors burn, where rare clouds form, where the atmosphere begins to transition from a place of substance to a place of near emptiness. The mesosphere is a forgotten layer, rarely mentioned, rarely considered, and yet it exists, a necessary part of the atmospheric structure, a link between the lower layers and the upper reaches. The thermosphere is a place of extremes. The temperature, in a certain sense, is very high, but the air is so thin that this temperature is almost meaningless. The molecules move quickly, energized by the sun, but they are so few and so far apart that they cannot transfer their energy to anything else. It is a paradox, a place that is both hot and cold, both full of energy and empty of substance. The thermosphere is where satellites orbit, where auroras glow, where the atmosphere begins to give way to the vacuum of space. And finally, the exosphere, the outermost layer, a place where the atmosphere is more concept than reality. The air here is so thin that it barely exists, molecules drifting in long, lazy arcs, some escaping into space, some falling back toward the planet. The exosphere is the final transition, the last whisper of the atmosphere before it fades into nothing. It is a place of ultimate stillness, ultimate quiet, ultimate isolation. The journey through the atmosphere is a journey from density to emptiness, from warmth to cold to warmth again, from movement to stillness. It is a journey that takes you farther and farther from the familiar, into realms that are increasingly alien, increasingly extreme. And yet, throughout this journey, you are always within the atmosphere, always surrounded by the thin shell of air that makes life on the surface possible. The atmosphere is patient. It does not rush, does not hurry, does not change dramatically from moment to moment. It exists in slow time, in geological time, in the time of planetary processes. It shifts and changes, but slowly, over years and decades and centuries. The composition of the air changes gradually, the temperature patterns shift subtly, the layers adjust to new conditions with a patience that is difficult to comprehend. The atmosphere is also resilient. It has weathered countless storms, countless changes in the sun's output, countless impacts from space. It has been shaped by volcanic eruptions, by the growth and death of forests, by the rise and fall of civilizations. And yet it persists, maintaining its overall structure, continuing to perform its essential functions, protecting the surface, supporting life, distributing heat and moisture around the planet. The atmosphere is a commons, shared by everyone and everything on the surface. The air you breathe is the same air that was breathed by people who lived hundreds of years ago, the same air that will be breathed by people hundreds of years from now. The molecules cycle endlessly, moving from lungs to air to plants to soil and back again, a constant circulation that connects all living things. The atmosphere belongs to no one and to everyone, a shared resource, a shared responsibility, a shared inheritance. As you continue to rise through the layers, you notice that the darkness of space becomes more apparent. The sky is no longer the bright blue of the troposphere or the slightly darker blue of the stratosphere. It becomes a deep, dark blue, then almost black, as the air thins and the scattering of light becomes less and less significant. The stars become visible, not twinkling as they do when viewed from the surface, but steady and bright, their light no longer disturbed by the movement of air. The sun, too, appears different, not softened by the atmosphere, but harsh and brilliant, its light unfiltered and direct. In the highest reaches of the atmosphere, the curve of the Earth becomes clearly visible. The horizon is no longer a flat line but an arc, a gentle curve that reveals the roundness of the planet. Below, the surface appears distant, covered in clouds or visible in patches, blues and greens and browns blending together in soft patterns. The atmosphere from this height appears as a thin, glowing shell, a delicate layer of light surrounding the dark mass of the planet. It is beautiful and fragile-looking, a reminder of how thin the layer of air really is, how precious and how vulnerable. The silence here is profound. There is no wind, no sound of any kind. The air is too thin to carry sound waves, and the isolation is complete. It is a silence that is almost tangible, a presence in itself, a quietness that seems to extend in all directions. It is a peaceful silence, not threatening or oppressive, but simply the absence of sound, the natural state of a place where there is almost nothing to make noise. Time seems different here, slower somehow, though of course it passes at the same rate as always. There is no rush, no urgency, nothing to disturb the stillness. The earth rotates slowly beneath, the sun moves across the sky in its predictable arc, and the thin air drifts gently, responding to forces that are too subtle to perceive. Everything happens in slow motion, in a kind of dreamlike state where change is almost imperceptible. The atmosphere at these heights is a place of extremes and contradictions. It is part of the earth, and yet it is almost space. It is filled with energy from the sun, and yet it is cold and empty. It is a place of protection, shielding the surface from radiation and debris, and yet it is so thin that it offers almost no substance, no resistance, no support. It is a place that exists in a kind of liminal state, neither one thing nor another, a transition zone between two very different realms. And yet, even here, even in the exosphere where the air is almost gone, there is still a connection to the surface. The molecules that drift through this outermost layer were once part of the air we breathe, the water we drink, the living things that inhabit the surface. They have risen, slowly, over time, carried by the gentle circulation of the atmosphere, until they reached this final layer, this last stop before space. Some will escape, drifting away into the void, lost to the planet forever. Others will fall back, pulled by gravity, descending through the layers until they rejoin the dense air below, ready to begin the cycle again. The atmosphere is a cycle, a circulation, a constant movement of air and water and energy. It is a system that is always in motion, always adjusting, always responding to the forces that shape it. The sun provides the energy, gravity provides the structure, the rotation of the earth provides the movement, and the result is a complex, beautiful, self-regulating system that has maintained the conditions for life for billions of years. As you continue to rise, to imagine yourself moving higher and higher through the atmosphere, you are moving toward stillness, toward silence, toward a place of ultimate calm. The busy troposphere is far below, the stable stratosphere is behind you, the cold mesosphere and the energetic thermosphere have been passed. You are approaching the edge, the final boundary, the place where the atmosphere merges with space and becomes indistinguishable from the void. Here, in this ultimate height, there is nothing but a few scattered molecules, drifting slowly, barely interacting, barely present. The Earth is far below, a sphere of blues and whites and browns, wrapped in its thin shell of air, glowing softly in the sunlight. The sun hangs in the black sky, brilliant and steady, its light reaching across the emptiness of space to illuminate the planet and its atmosphere. The stars surround you, countless points of light scattered across the darkness, each one a distant sun, each one surrounded perhaps by its own planets, its own atmospheres. The atmosphere has brought you here, carried you upward through its layers, from the dense, familiar air of the surface to this place of ultimate thinness, ultimate quiet. It has been a gentle journey, a slow rise through zones of changing temperature and pressure, through regions of different character and different roles. And now, at the end of this journey, you find yourself in a place of profound peace, a place where there is nothing to disturb you, nothing to demand your attention, nothing but the slow drift of molecules and the steady light of distant stars. This is the edge of the atmosphere, the boundary between the Earth and space, the place where the planet's influence finally fades away. It is a place of transition, a place of endings and beginnings, a place where the familiar gives way to the unknown. And yet it is also a place of connection, a reminder that the Earth is not isolated, not alone, but part of a larger system, a solar system, a galaxy, a universe. The atmosphere has done its work, bringing you to this place of calm, this place of quiet, this place of rest. Below, the layers continue their slow cycles, the troposphere churning with weather, the stratosphere filtering the sun's rays, the mesosphere catching meteors, the thermosphere glowing with auroras. Above, space extends infinitely, dark and empty and silent, filled with possibilities and mysteries. And here, in this thin edge between them, you rest, suspended in the final whisper of the atmosphere, surrounded by the quiet, the stillness, the gentle dark. There is nothing more to rise toward, nothing more to reach for, only this moment of perfect calm, this place of ultimate peace, this quiet ending that is also a beginning, this place where the atmosphere finally fades, leaving you in the gentle embrace of silence and space. The journey is complete, the layers traversed, the atmosphere explored from bottom to top, from the dense air of the surface to the thin emptiness of the exosphere. And in this completion, there is rest, there is quiet, there is peace. The atmosphere holds you gently, even here at its outermost edge, a final reminder of the planet below, a final connection to the world you know, before it releases you into the stillness beyond.